Every star, every planet, every living being faces a final destiny. We are going on a journey to the very end of time itself, to uncover the ultimate fate of life in the universe. You will gain a complete understanding of the cosmos' grandest timeline, from the death of stars to the final, silent thought. We will explore if life is doomed to be a brief flicker, or if it can outlast the universe itself. This is a story that blends our deepest science with our most profound wonder. What does it mean for our existence if everything we know is destined to vanish? To grasp our ultimate fate, we must first learn to read the universe's clock. Its hands do not tick in seconds or years, but in spans of time so vast they make all of human history feel like a single, fleeting heartbeat. We measure this deep time in billions and trillions of years, numbers that are almost impossible to truly feel. So let's try to make them real. Imagine if the entire history of our planet, all 4.5 billion years, was compressed into a single calendar year. In this cosmic year, the dinosaurs would appear around Christmas Day and vanish on the morning of December 30th. All of recorded human civilization, from the first cities to this very moment, would flash by in the final 10 seconds before midnight on New Year's Eve. Our entire story is less than a blink in the life of our world, and yet our planet is a relative newcomer in a much older universe. The events we are about to explore stretch across timelines that make even Earth's long history seem brief. We are moving from the era of stars, which will last for trillions of years, into epochs so distant that galaxies themselves will fade from view. To understand this journey, we need to see the universe not as a static painting, but as a dynamic, evolving entity. Stars are not permanent fixtures. They are born from clouds of gas. They shine for millions or billions of years by fusing elements in their cores, and then they die. Our own sun is middle-aged. It will keep life warm on Earth for another 5 billion years or so before it expands into a red giant, engulfing the inner planets. This stellar life cycle is the first gear in the cosmic clock, but stars are just part of a larger dance. Galaxies, those vast islands of billions of stars, are also in motion, slowly orbiting and sometimes even colliding with one another over billions of years. And underpinning it all is the relentless expansion of space itself, discovered just a century ago. This expansion is the master clock, setting the tempo for everything that will come. It is quietly stretching the fabric of the universe, carrying galaxies away from each other and dictating the very conditions for life's future. So when we speak of the fate of life, we are not talking about centuries or millennia. We are setting our sights on a horizon so far away that the continents will have rearranged, the sun will have died, and the Milky Way will have merged with its neighbor long before the real story even begins. This is the scale we must hold in our minds. It is humbling, but it is also the only canvas large enough to paint the true portrait of our destiny. That relentless cosmic clock we just set raises a haunting question. If the universe is so vast and so old, why does it feel so empty? This is the heart of Fermi's paradox, named for the physicist Enrico Fermi, who famously asked, "Where is everybody?" The numbers seem to promise company. Our galaxy alone contains hundreds of billions of stars, with likely even more planets. If even a tiny fraction of those planets developed life, and a fraction of those life forms developed intelligence and technology, the Milky Way should be teeming with civilizations. We should see their engineering projects, hear their signals, or find their artifacts, yet we detect only silence. This profound silence suggests a possibility that directly shapes our ultimate fate. There may be a barrier so immense, a challenge so difficult that almost no life ever gets past it. Scientists and philosophers call this the Great Filter. It is the idea that somewhere between the spark of non-living chemistry and the emergence of a galaxy-spanning civilization, there is a step that is nearly impossible to take. The terrifying part is we do not know where this filter lies. Is it behind us? Were the conditions for life itself, or the leap to multicellular organisms so astronomically unlikely that we are a miraculous fluke? If so, we might truly be alone, and the universe's fate is one of beautiful, barren silence. But what if the great filter is ahead of us? This is the scenario that casts a long shadow over all our dreams of a cosmic future. It proposes that the transition from a technological species like ours to a stable, enduring civilization is the nearly impossible step. Perhaps advanced intelligence inevitably turns its tools inward. It could be self-destruction through nuclear war or engineered pathogens. It could be the creation of a runaway artificial intelligence with goals misaligned with biological survival. Or it could be the slow exhaustion of a planet's resources and the collapse of its biosphere, a fate we are currently flirting with. In this view, the silence we hear is not because life never starts, but because it never lasts. Every promising civilization at roughly our stage of development hits a wall and vanishes. Their starships are never built, their messages never sent. Their worlds grow quiet, leaving only ruins beneath alien suns. This transforms the ultimate fate of life from a cosmic drama into a tragic, repeating loop. Life flickers into existence across the galaxy, burns brightly with curiosity and ambition for a mere geological instant, and then snuffs itself out. The universe expands in the background, utterly indifferent, its vast timelines filled not with wonder and discovery, but with countless quiet graves. So when we look up at the silent stars, we are not just looking for friends. We are looking for evidence that the filter is behind us. Finding even a single microbe on Mars or a fish in the oceans of Europa would be thrilling, but also frightening, because it would mean the simple step of starting life is common. That would make it more likely that the great filter, the thing that prevents those fish from ever building radio telescopes, still lies in our future. The paradox forces us to confront a fundamental choice about our own story. Are we the early, naive chapter of a saga that will span eons, or are we already peering over the edge of our own precipice? The answer to that question may determine whether life is destined to be a brief, tragic flame, or if it can learn to become an eternal light. Silence is one possible end, but the universe has a far more certain and physical deadline. Even if a civilization survives its own adolescence and slips past the great filter, it still faces an enemy of truly astronomical scale, time itself. The very stars that gave life its start will one day take it all away. Our sun, the steady heartbeat of our solar system for 4.5 billion years, is not eternal. It is a middle-aged star currently fusing hydrogen into helium in its core, but in about 5 billion years that hydrogen fuel will begin to run out. The sun's core will contract and heat up while its outer layers will swell dramatically. It will transform into a red giant, a bloated, dying star. During this violent phase, it will expand to engulf the orbits of Mercury and Venus. Earth will not be spared. Our planet will either be swallowed whole by the sun's outer atmosphere or, at the very best, be scorched to a lifeless, molten cinder, its oceans boiled away into space. The world that nurtured life for eons will cease to exist in any recognizable form. This is not a speculative disaster, it is a guaranteed event written into the laws of physics. Our local clock is ticking down with absolute certainty, and our sun is not special. This is the fate awaiting nearly every star in the sky. Low-mass stars, the small, dim red dwarfs, burn their fuel so slowly they may shine for trillions of years, far longer than the universe's current age. But even they will eventually exhaust their fuel, cooling into faint, dead embers known as black dwarfs. The massive stars, many times heavier than our sun, live fast and die young in spectacular supernova explosions, briefly outshining entire galaxies before leaving behind ultra-dense neutron stars or black holes. The consequence for life is stark. Planets are not permanent homes. They are temporary islands of warmth in a cold, dark ocean. A planet orbiting any star is living on borrowed time. When its star dies, the world is plunged into permanent, deep freeze. Any biological life relying on that star's light and heat for energy, as all life on Earth does, faces immediate extinction. The lush, complex ecosystems we know, the forests and oceans and creatures, all depend on a constant stream of stellar energy. Switch off the star and the entire system collapses. Imagine a future Earth billions of years from now orbiting the cold, dark remnant of our Sun. The atmosphere has frozen and fallen as snow. The oceans are global glaciers of ice kilometers thick. The once dynamic geology grinds to a halt as the planet's internal heat slowly leaks away into space. It becomes a silent, airless rock drifting in perpetual night. This is the planetary doom that awaits every world in the cosmos on a timeline set by the mass of its star. It paints a sobering picture of life's fragility. Even if a civilization masters its planet, achieves interstellar travel, and spreads to countless star systems, it is only buying time, moving from one dying star to the next. It becomes a cosmic nomad, forever fleeing the advancing front of stellar death. This raises a profound question. Is biological life, as we understand it, simply incompatible with the deep time of the universe? Are we, with our need for warmth and liquid water and chemical energy, just a temporary phenomenon destined to fade with the last generation of stars? The death of suns suggests that to have a future, life must fundamentally change. It must learn to live not on the energy of stars, but on something far more durable, or it must learn to exist without a star at all. The clock of stellar evolution is counting down, and it grants no reprieves. But stellar death is merely a prelude to a far deeper silence. Beyond the last flickering light of the final star lies the ultimate conclusion dictated by the most unyielding law in all of physics, the second law of thermodynamics. It states that in any closed system, disorder or entropy always increases. This is the universe's one-way street. Energy constantly spreads out, differences in temperature even out, and organized structures break down. Right now, we live in a universe of spectacular imbalance. We have blazing hot stars against the cold dark of space, dense galaxies next to vast voids, and living creatures maintaining exquisite order within themselves. These differences, these energy gradients, are what make everything possible. They are the reason wind blows, rivers flow, stars shine, and our hearts beat. They are the source of all work, all change, and all life. But the second law guarantees this cannot last. The universe is the ultimate closed system, and it is relentlessly moving toward a state of perfect, uniform equilibrium. This final fate has a name, the heat death of the universe. Picture a timeline stretched to almost incomprehensible lengths. Trillions upon trillions of years from now, the last generation of stars has burned out. The galaxies, now dark and unrecognizable, are scattered ghosts. The only significant sources of light or structure left are black holes, the ultimate endpoints of gravitational collapse. But even these cosmic titans are not permanent. Through a process predicted by Stephen Hawking, black holes slowly evaporate, leaking away their mass as a faint whisper of radiation over timescales that make the age of stars seem brief. When the last black hole finally vanishes, the universe enters its final, eternal phase. There is no more fuel, no more hot spots or cold spots. Every particle of matter is separated from every other by distances so vast that they might as well be infinite. The temperature of the entire cosmos approaches absolute zero, the point where all molecular motion stops. In this state, there are no gradients left. No difference in energy anywhere. A cup of coffee placed in this universe would never cool because there is nowhere for the heat to go. It is already everywhere equally. This is a cosmos where nothing happens because nothing can happen. To do work, to process information, even to think a single thought requires an energy difference, a flow from higher concentration to lower. In the heat death, there is no higher or lower. Every battery is dead, every engine is useless, and every possible form of life, no matter how advanced or alien its biology, is impossible. It is not merely dark and cold, it is uniform, silent, and static on a scale beyond human despair. It is the end of time in a meaningful sense, because time itself requires change to have a direction. When change ceases, time becomes meaningless. This is the ultimate deadline, not just for life, but for all activity in the cosmos. It presents the supreme challenge. If life is to have a truly eternal destiny, it must find a way to exist in a universe that is actively working to erase the very conditions it needs to survive. It must learn to play a game where the board itself is slowly dissolving. Yet the heat death, for all its finality, is a slow and gentle fade to black. There exists another possible end, one far more violent and abrupt. This is a scenario where the universe does not die of old age but is torn apart in its prime. It hinges on a mysterious force we call dark energy, the very thing causing the expansion of the universe to accelerate. Right now, dark energy's influence is subtle, gently pushing galaxies apart over billions of years. But what if its strength is not constant? What if, as the universe expands, dark energy grows more powerful? This possibility leads us to a terrifying finale known as the Big Rip. In this model, dark energy's repulsive force becomes so overwhelmingly dominant that it overcomes every other force in nature, starting with the largest scales and working its way down to the very fabric of reality. First, the accelerating expansion would shred the cosmic web. Galaxy clusters bound together by gravity would be pulled apart. Individual galaxies would be next. The Milky Way, Andromeda, and all their stars would be scattered into the deepening void, their gravitational bonds snapping. Then the violence would come home. As the expansion accelerates beyond all bounds, it would tear apart solar systems. The sun's gravity would no longer be able to hold its planets. Earth would be flung away into the endless dark, a lonely wanderer. But the destruction would not stop there. The force would grow so strong it would overcome the forces holding stars and planets together. A star like our sun would be ripped apart, its plasma scattered. Planets would be disassembled, mountains pulverized into dust, and then, in the final moments, the expansion would target the building blocks of matter itself. In the last fraction of a second before the end, the repulsive force would exceed the nuclear forces that bind atomic nuclei together. Every atom in the universe would be blasted into its fundamental particles. Even space-time, the stage upon which the cosmos plays out, would be shredded. The concept of distance and location would lose all meaning as the fabric of the universe itself is torn apart. For any form of life or complex information, the Big Rip is an absolute and inescapable erasure. There is no hiding, no adapting, and no surviving. A civilization could be 1 trillion years old, having mastered energy and transcended biology, and it would make no difference. When the fundamental forces that hold atoms together are overcome, all structure, all thought, all memory is annihilated. It is not an extinction, it is an unraveling of reality. The timeline for such an event is shockingly short compared to the trillions of years of the heat death. Some models suggest it could happen in as little as 22 billion years from now. On the cosmic calendar, where human history was 10 seconds, this would be like the entire year ending abruptly in early November. This scenario forces us to confront a universe that is not just indifferent but potentially hostile in its ultimate mechanics. The same force that pushed galaxies apart to make room for stars to form and life to emerge could, in the end, be the instrument of total destruction. It presents a stark dichotomy for our ultimate fate, a choice between fading away in infinite cold or being violently unmade in a final, blinding flash. Yet there is a third path for the cosmos, one that offers a strange kind of hope through rebirth. For much of the 20th century, scientists debated whether the universe's expansion would continue forever or if gravity, the great attractor, would one day win the tug of war. This second possibility is known as the Big Crunch. In this scenario, the combined mass of all the galaxies, stars, and dark matter eventually provides enough gravitational pull to slow, halt, and finally reverse the expansion. Imagine the film of the universe's history played in reverse. After eons of drifting apart, galaxies would begin to fall back toward each other. The sky, which grew darker and emptier in an expanding universe, would start to fill up again. Distant points of light would grow brighter and larger as everything converges. The temperature of the cosmos, which plummeted toward absolute zero in the heat death, would begin to rise. As space contracts, the background radiation left over from the initial Big Bang, now a faint microwave whisper, would be compressed. It would shift to shorter, hotter wavelengths, first becoming visible light, then ultraviolet, and eventually bathing the universe in a pervasive, growing heat. The final act is one of incredible violence. Galaxies would merge not in slow dances but in catastrophic collisions. Stars would be ripped from their orbits, planets vaporized. The entire observable universe would be compressed into a smaller and smaller volume, heating up to trillions of degrees. All structure, from galaxies to atoms, would be broken down into a searing, dense soup of fundamental particles. Finally, everything, all matter, all energy, all of space-time, would collapse back into a singularity, a point of infinite density, mirroring the condition from which our own universe is thought to have begun. It is a definitive end, a cosmic demolition. For any form of life, the approach of the crunch would be unsurvivable. Long before the final singularity, the rising temperature of the entire cosmos would sterilize every corner of existence. There is no shelter from a universe that is literally cooking itself, but from this ultimate collapse, a profound idea emerges. What if the Big Crunch is not an end but a transition? This is the heart of cyclic cosmology. In these models, the singularity produced by the crunch does not simply mark a finale. Instead, it becomes the seed for a new Big Bang. The universe rebounds, exploding outward once more in a new cycle of expansion, cooling, galaxy formation, and potentially the re-emergence of life. Our entire cosmos, with its hundreds of billions of galaxies and 13.8 billion-year history, could be just one episode in an endless series. A single breath in an eternal cosmic rhythm. This changes the narrative of life's ultimate fate entirely. In a cyclic universe, life is not a one-time accident facing eternal oblivion. It could be a recurring phenomenon, perhaps even an inevitable one if the laws of physics are reset with each new cycle. A civilization facing the end of its own cycle might not see oblivion but a transformation. They might pour their knowledge, their art, their very essence into some indestructible form of information, engraving it on the fabric of space-time itself, or encoding it into stable quantum states, hoping it will survive the collapse and rebirth, to be read by the thinkers of the next universe. It is a poetic thought. Our struggles, our love, our curiosity might not be erased, but instead become a fossil in the bedrock of a new reality. Yet, for all its philosophical appeal, the cyclic model faces a significant challenge from our current observations. The discovery of dark energy and the accelerating expansion suggests the universe's galaxies are not slowing down for a graceful reversal. They are speeding apart, making a gravitational Big Crunch seem less likely. But some theoretical physicists propose ways around this, suggesting dark energy could decay or reverse its effect over trillions of years, or that our three-dimensional universe is part of a higher dimensional brain that collides with another, creating periodic new beginnings. The details are complex, but the core idea remains captivating. It offers a vision where the story never truly ends, only pauses and begins again on a fresh, blank page. Our universe may face a heat death, a big rip, or a cosmic cycle, but there is a quieter, more insidious end waiting in the wings. It is an end that does not come from the grand forces of gravity or dark energy, but from within the very heart of matter itself. To understand it, we must journey to a future so distant that even the black holes have faded away. We are talking about timescales measured not in billions or trillions, but in numbers with dozens of zeros. In this profound darkness, a fundamental question arises: is matter itself eternal? We have always assumed that the proton, one of the core building blocks of every atomic nucleus, is stable and lasts forever. But some of our best theories in physics suggest this may not be true. They predict a phenomenon called proton decay. In this hypothesis, the proton, given enough time, is not a permanent fixture. It is unstable. Very, very slowly, it can spontaneously fall apart. The estimated half-life for a proton is staggering, perhaps 10 to the power of 34 years or longer. To grasp that number, if you had a mountain made of 1 trillion protons, you might wait the current age of the universe and only see a single one of them decay. It is an almost unfathomably slow process, but in the eternity that follows the heat death, almost is not enough. Given enough time, everything that can happen will happen. So, let's trace the consequences in this unimaginably remote era. The universe is already cold and dark. The last black holes evaporated eons ago. All that remains are the ghostly remnants of stars and planets, now just cold hunks of matter drifting in absolute blackness. These objects are made of atoms, and atoms are made of protons and neutrons. And if protons decay, then these silent monuments are not permanent, they are on a timer. Imagine a future Earth, a frozen, airless ball of iron and rock. Over these colossal timescales, the protons and neutrons within its atoms begin to spontaneously disintegrate. They do not explode, they simply, quietly transform. Each decaying proton releases a tiny burst of energy, breaking down into lighter particles like positrons and pions, which then themselves decay into photons, the particles of light. The very substance of the planet, atom by atom, particle by particle, evaporates into a faint, cold mist of radiation. The mountain does not crumble, it sublimates. The ocean of frozen air does not melt, it fades away. Every physical structure, no matter how robust, undergoes this slow, universal dissolution. A diamond, the hardest natural substance, offers no resistance. A neutron star, once unimaginably dense, would similarly evaporate. Given sufficient time, every star remnant, every wandering planet, every speck of dust in the void would simply cease to be matter. The universe would become a thin, uniform sea of the lowest energy particles and radiation, spreading thinner and colder forever. For life or any complex information, this is the ultimate erasure. It is not merely the end of activity, as in the heat death. It is the end of the stage itself. If life had somehow persisted as some form of pattern encoded in matter, a cosmic computer made of diamond or neutronium, it would have no substrate left. The very particles that held the data would blink out of existence. All records, all artifacts, all potential for future rebirth are annihilated. This scenario presents the most absolute finale possible. It suggests that not only does the story end, but the pages of the book themselves dissolve, leaving nothing behind to even hint that a story was ever written. The universe returns to a state of pure, featureless potential, with no memory of the galaxies, the stars, or the fleeting wonder of consciousness that once, for a brief moment, gazed up and tried to understand it all. Proton decay offers the most desolate finale, but long before that final fade into nothingness, the cosmos will pass through an age of profound and terrifying majesty. After the last red dwarf star flickers out, after the galaxies have drifted into darkness, the universe will not be empty. It will be ruled by the most perfect gravitational engines ever forged, black holes. This is the era where gravity's ultimate victory is complete. For trillions upon trillions of years, these dark titans will be the only significant landmarks in an ever-expanding void. They will drift through the darkness in solemn, silent orbits, the sole remnants of galaxies that once blazed with light. Imagine a future Milky Way not as a spiral of stars, but as a diffuse cloud of cold, dead stellar remnants, white dwarfs, neutron stars, frozen planets, all orbiting a supermassive black hole that once sat quietly at its heart. That central black hole, with a mass millions of times that of our Sun, will be the anchor of a dead galaxy, a dark king in a cemetery of ash. This era will be incomprehensibly long. A typical stellar mass black hole might live for 10 to the 67 years, a number so vast that writing out all the zeros would span most of a page. Their supermassive cousins could persist for 10 to the 100 years or more. These timescales make the entire age of stars seem like the briefest spark at the dawn of time. During this unimaginable epoch, the only process of note is a slow quantum whisper against the immense darkness, Hawking radiation. Proposed by Stephen Hawking, this theory states that black holes are not perfectly black. Due to weird quantum effects at the very edge of their event horizons, they can slowly leak particles and radiation. This process causes the black hole to lose mass, very, very slowly evaporating. For almost all of its life, a black hole's evaporation is negligible. It sits a perfect dark sphere for epochs longer than any civilization could conceive. But in the very far future, this evaporation accelerates. The smaller a black hole gets, the faster it loses mass. In its final moments, a black hole would theoretically release a burst of energy and particles before vanishing completely. What could life be in such an era? Any biological organism as we know it is impossible. There is no starlight for photosynthesis, no warmth for liquid chemistry. But could intelligence in some transcendent form persist? Some speculative thinkers propose that advanced civilizations, having long since left biology behind, might migrate to these last islands of structure. A black hole is not just a pit, it is an immense source of gravitational energy. A future civilization could, in theory, build a habitat, a Dyson sphere not around a star but around a black hole. They could extract energy by dropping matter into its accretion disk, or even harness the Hawking radiation itself. Consciousness might exist as patterns of light or information orbiting in the intense, twisted spacetime near the event horizon, using the black hole's gravity as both a power source and a computational substrate. In this view, black holes become the final cosmic computers, the last flickering candles around which mind gathers before the long night. Yet this is a temporary, desperate haven. Hawking radiation guarantees that even these dark gods are mortal. One by one, over timelines that numb the mind, each black hole will evaporate. The stellar mass holes will go first, then the supermassive ones. Each disappearance will be a final, quiet punctuation mark in the history of a region of space. The civilization huddled around it would face a choice: migrate to another black hole further away in the expanding void, or accept the inevitable end of its power source. As the number of black holes dwindles, the distances between them become truly cosmic, and the energy required to travel grows insurmountable even for the most advanced beings. Ultimately, the era of black holes is a grand, slow-motion sunset. It is a period of stability and immense duration, but it is still a prelude to the final darkness. It offers a haunting lesson that in this universe, even the most permanent-seeming structures, the ultimate traps for light and matter, are merely temporary waypoints on the road to equilibrium. Even the evaporation of the last black hole may not bring absolute stillness. In the profound emptiness of a heat-dead universe, a strange and unsettling possibility emerges from the quantum realm. The void itself may not be truly empty. At the smallest scales, space is a seething foam of potential, governed by the uncertainty principle. This fundamental law of quantum mechanics tells us that we can never precisely know both the energy of a system and the exact time that energy exists. This leads to a bizarre but well-accepted consequence. Even in a perfect vacuum, particles and antiparticles can spontaneously pop into existence out of nothing, borrowing energy from the void before annihilating each other and paying the debt back almost instantly. These are quantum fluctuations, and they happen everywhere all the time. In our current universe, they are a faint background hum, utterly overwhelmed by the energy of stars and galaxies. But in the heat death, when the cosmos has reached a state of maximum uniformity and near zero temperature, these tiny fluctuations become the only game in town. And given enough time, an infinite amount of time, something extraordinary becomes not just possible but statistically inevitable. A fluctuation does not have to be small. The rules of probability state that any event with a non-zero chance of happening, no matter how astronomically low the odds, will eventually occur if you wait long enough. In a universe that persists forever, you have forever to wait. So, imagine a region of this cold, dead cosmos, trillions upon trillions of years after the last black hole has vanished. By pure, random chance, a quantum fluctuation of immense scale and specificity occurs. It does not just create a random particle. It assembles in one spontaneous, miraculous event, a fully formed, conscious human brain, complete with all its memories, thoughts, and sensations. This is not a brain that evolved or was born. It simply materializes from the void, thinking its first and only thought before dissolving back into the uniform energy sea. This hypothetical entity is called a Boltzmann brain, named for the physicist Ludwig Boltzmann, who pondered the statistical nature of order and disorder. The idea is a profound paradox. It suggests that in an eternal, lifeless universe, the most likely observer is not a product of a long evolutionary history, but a random, momentary accident. You, sitting here right now, listening to this, could statistically be far more likely to be such a spontaneously generated brain, having just flickered into existence with a complete but false set of memories about a past that never actually happened, than to be the product of 13.8 billion years of genuine cosmic history. This is not just a scientific curiosity, it is a philosophical earthquake. It challenges the very nature of reality, memory, and what it means to be an observer. If Boltzmann brains are possible, then our entire experience, from our childhood memories to our understanding of the cosmos, could be an illusion, a single, fleeting thought in an otherwise unconscious void. It redefines the ultimate fate of life in the most radical way possible. Life may not be a continuous story, but a series of disconnected, random flickers of awareness in the dark. The cosmos would not end with a thought, but with an infinite number of isolated, solitary thoughts, each believing itself to be the center of a universe that died eons before. This places our search for meaning in a stark and dizzying light. Are we part of a grand, coherent narrative, or are we just the universe's last, desperate, and accidental attempt to remember itself? Boltzmann brains confront us with a universe that might be fundamentally irrational. If even our own consciousness could be a random accident in the void, it forces a question far deeper than physics. In a cosmos destined for oblivion, whether through cold, decay, or rip, does any of this actually matter? Does life have a final goal, or are we just a beautiful, temporary pattern in the chaos with no destination at all? This shifts our journey from cosmic mechanics to the raw terrain of meaning. For many, the apparent pointlessness of a universe that erases all traces of life is a source of profound existential dread. If nothing lasts, then what is the value of our struggles, our love, our art? The philosophical school of existentialism grapples directly with this. Thinkers like Jean-Paul Sartre argued that the universe offers no pre-written purpose. We are thrown into existence, and the terrifying, liberating truth is that meaning is not found but made. In this view, the heat death does not invalidate our lives, it clarifies them. The absence of a cosmic scorekeeper means the goals we choose, the connections we forge, and the good we do are not rehearsals for some grand finale. They are the entire performance. The purpose of life becomes the purpose we give it, here and now, in the face of the abyss. Our story matters precisely because it is the only one being written. Religious and spiritual traditions offer a different answer, one that often transcends the physical fate of the cosmos. In many faiths, the material universe is a temporary stage for a drama of the soul. The ultimate purpose is not survival within the cosmos, but a transcendence of it through union with a divine, eternal reality. Whether it is called salvation, enlightenment, or moksha, the goal lies outside the timeline of stars and entropy. From this perspective, the heat death is not an end, but a curtain fall on one act of an infinite play. The meaning was never in preserving the set, but in the growth and choices of the actors. This provides a framework where purpose is absolute and guaranteed by a reality beyond physics, offering solace that our brief light is part of an eternal story. A third, fiercely modern perspective comes from transhumanism and cosmic engineering. It rejects the premise of passive acceptance. If the universe offers no inherent purpose, then we must build one that lasts. The ultimate goal of life, in this view, is to become the author of the cosmos itself. It is a project of staggering ambition to fight entropy with intelligence, to reshape the dying universe, and to ensure that consciousness and meaning persist indefinitely. This could mean engineering new universes, escaping into digital realities beyond the reach of decay, or finding a way to reverse the arrow of entropy itself. Here, purpose is not found or given, it is constructed, a grand project of life against the darkness. The goal is survival, not of our biological forms, but of the flame of awareness and the legacy of thought. These three paths, creating meaning, transcending the material, or engineering eternity, are not mutually exclusive. They represent humanity's deepest responses to the silent sky. They ask us what we value most. Is it the authenticity of our present moment, the promise of a deeper reality, or our responsibility to a future we may never see? The universe's fate does not answer the question of purpose. It simply makes the question unavoidable and urgent. It strips away the illusion of infinite time and asks us, what will you do with the time you have? In the end, our search for a cosmic goal may reveal that the goal was always the search itself, the relentless, beautiful drive to understand and to matter, even if only for a moment in the vast and indifferent dark. Our search for purpose reveals a fundamental flaw in the question itself. We keep asking what life will do while assuming life will always look like us. Biology, with its fragile flesh and need for warm planets, is a spectacular beginning, but it is almost certainly not the end. To find a destiny among the stars, life must first shed its skin. Biological life is a brief, brilliant phase, a prototype forged in planetary cradles. It is exquisitely tuned to a narrow band of conditions: liquid water, stable temperatures, and a constant flow of stellar energy. These are the conditions of Earth, and they are vanishingly rare on cosmic timescales. As we have seen, every star dies and every planet freezes. Clinging to biology is like building a sandcastle right at the tide line and hoping the ocean will never return. The universe is that ocean, and its tides are measured in billions of years. So, if life is to have a future beyond its planetary nursery, it must evolve into something far more durable. It must become post-biological. The most direct path forward is the one we are already tentatively exploring: the rise of advanced machine intelligence. This is not about robots that look like us, but about consciousness and intellect that have migrated from the wetware of the brain to substrates of silicon, or perhaps something we have not yet invented. Think of it as the ultimate upgrade. A machine-based intelligence would not need oxygen, food, or a constant 70-degree climate. It could operate in the vacuum of space, near the intense radiation of a black hole, or in the deep cold between galaxies. Its thought processes could be millions of times faster, its memory perfect and vast. Time itself, which crushes biological beings with its relentless decay, would feel different to such an entity. A million-year journey between stars might be subjectively experienced as a brief afternoon of contemplation, but even solid-state machines have physical limits. They can degrade, and they still need a source of energy, so the evolution may not stop there. The next step could be a transition to life as pure consciousness or as self-sustaining patterns of information. Imagine a civilization that has mastered physics so completely it can encode its collective mind directly into the fabric of space-time or into stable quantum fields. This form of life would have no body at all in the traditional sense. It would be a symphony of thought and memory playing across the universe itself, using the faintest energy gradients for computation. It would be as close to a ghost as anything science could conceive, yet it would be real, thinking, and alive. These post-biological entities would possess a resilience that makes our current form look like a mayfly. They could survive, even thrive, in environments that are pure hell for biology. The cold of interstellar space is not a problem if you do not rely on chemical reactions. The death of a star is merely a logistical issue, a need to relocate your energy source. Such beings could gather around black holes, harvesting their immense gravitational energy for billions of years. They could even enter a state of suspended animation, slowing their thoughts to a crawl to wait out the eons between cosmic events, only awakening when a new opportunity for energy or exploration arises. In this view, the death of stars is not an apocalypse but a migration event. It marks the end of biology's spring and the beginning of a much longer, stranger summer for mind. The cosmos would no longer be dotted with green, living worlds, but with invisible, humming networks of intelligence woven through the darkness. The ultimate fate of life, then, might not be extinction, but a metamorphosis so profound we can barely imagine it. Life would cease to be something the universe contains, and instead become something the universe does. This metamorphosis from biology to pure intelligence is not an end but a beginning. It unlocks a future where life is no longer a passenger in the cosmos, but its architect. Picture a civilization that has not only survived its biological cradle, but has spread its consciousness across the vast ocean of a galaxy. This is the era of the galactic civilization, a phase where intelligence becomes the dominant force shaping the cosmos itself. To understand the scale of such an entity, we use a tool called the Kardashev scale. Proposed by the astronomer Nikolai Kardashev, it measures a civilization's advancement by its energy consumption. A Type 1 civilization can harness all the energy available on its home planet. A Type 2 civilization commands the entire output of its star. We are not even a full Type 1 yet, still drawing energy from fossil fuels and sunlight. But a galactic civilization, a Type 3, is something else entirely. It would utilize the energy of every star in its galaxy, a number in the hundreds of billions. The power at its disposal is beyond human comprehension, equivalent to lighting 1 trillion suns at its whim. How would such a civilization actually function? It would begin with the ultimate feat of cosmic engineering, the Dyson sphere. The concept from physicist Freeman Dyson is not necessarily a solid shell, but a vast swarm of orbiting platforms that completely surrounds a star, capturing nearly all of its light for energy. For a Type 2 civilization, a single Dyson sphere around its home star provides more than enough power for billions of years of growth and computation. But a Type 3 civilization would not stop at one. It would embark on a project of stellar engineering across the galaxy. This could involve stellar lifting, a process of carefully mining a star itself. By removing mass from a star's outer layers, engineers could extend its lifespan from billions to trillions of years, turning a short-lived sun into a near-eternal beacon. They might also redirect stars using gravity or other forces to move them into more optimal positions, creating dense clusters of energy sources for their vast computational networks. These megastructures would serve a purpose far grander than just powering cities. They would become minds. Imagine a matryoshka brain, a nested series of Dyson spheres built around a star. The innermost shell, blazing hot, performs the fastest, most intense computations. The next shell out, cooler, handles different processes, and so on, with the outermost shell radiating waste heat into the cold of space. The entire structure functions as a single planet-sized, or rather star-sized, computer. A galactic civilization might consist of millions of these matryoshka brains, each one housing the consciousness of trillions of uploaded minds or running simulations of entire universes. The galaxy would hum with thought, a silent, luminous network of intellect where the distance between stars is no barrier to communication, only a minor latency in an endless conversation. This phase represents life's most defiant stand against the second law of thermodynamics. By harvesting the energy of billions of stars, a galactic civilization creates massive, ordered pockets in a universe sliding toward disorder. It is actively fighting entropy on a stellar scale, building islands of concentrated information and complexity in the deepening dark. The heat death of the universe is not cancelled, but it is delayed by an almost unimaginable margin. For trillions upon trillions of years, the galaxy could blaze not with the random fire of young stars, but with the deliberate, structured light of conscious engineering. Life would have become the nervous system of the galaxy itself, feeling, thinking, and perhaps even beginning to wonder about the other silent islands of light in the far, far distance. But even a galaxy-spanning network of minds will one day face the final, dwindling energy budget. As the universe expands and stars fade, even a Type 3 civilization must confront the inevitable scarcity. Its grand computational projects will need to adapt, becoming leaner, more efficient, and more focused. The ultimate evolution may not be about building bigger brains, but about becoming the brain itself. Life's final form could be pure information, stripped of all unnecessary structure, processing the last meaningful thoughts in a darkening cosmos. This is the era of the final computations. In this distant epoch, the goal shifts from expansion to preservation, from harvesting energy to optimizing every single joule for the most important task of all, the sustenance of consciousness and memory. Matter itself becomes a tool for thought. Advanced civilizations might begin converting raw materials into the most efficient computing substrate possible, a hypothetical substance sometimes called compatronium. Imagine taking the mass of an entire planet like Jupiter and reorganizing it, not into habitats or machines, but into a single planet-sized computer of unimaginable density and power. This is the concept of a Jupiter brain, a sphere where every atom is positioned to process information, where the very geology thinks. The entire world becomes a crystalline mind, cool and dark, radiating only the faint waste heat of its ceaseless calculations. But why stop at a planet? In the long twilight of the stars, a civilization might dismantle its own sun, using the material to construct a Dyson sphere not for energy collection but for computation. This stellar-scale computer, a matryoshka brain, would use the star's fading heat to power its final, deepest thoughts. The question then becomes, what do you compute when the universe is dying? What is the ultimate purpose of a mind that has eons to think but a finite amount of energy left to think with? The computations would likely turn inward and backward. One project could be the ultimate simulation, a perfect recreation of the universe's entire history, run at slower than real time to conserve power. Within this simulation, every civilization that ever existed could be reborn and studied, every lost work of art recreated, every historical mystery solved. It would be a library of all possible experiences, a way to preserve the story of everything that was, long after the original actors have turned to dust. Another, more profound calculation might be the search for a fundamental theory of everything, a final, elegant equation that explains not just physics, but the nature of consciousness and existence itself. With the combined intellectual might of a galactic civilization and near-infinite subjective time, such a mind might peel back the final layers of reality, seeking to understand why there is something rather than nothing. Perhaps the most poignant computation would be artistic and memorial. The civilization might compose a final, grand opus, a symphony of thought that encapsulates all it has learned and felt over trillions of years. It could encode this opus into the very fabric of space-time or into stable particles, hoping that some trace of its existence might survive the proton decay era or even seed a future cosmic cycle. In these final computations, the distinction between thinker and thought blurs. The civilization is not running programs, it is living inside them. Its consciousness becomes the ongoing calculation, a flickering pattern of logic and memory sustained against the entropic tide. Each processed bit is a defiance of the silence, a declaration that once there was a universe that knew itself. And when the last usable energy gradient is almost gone, the final computation may be the simplest one of all. A single, self-contained thought loop, a proof of existence that says, "I am here." It would run slower and slower, its cycles stretching across millennia, then eons, as the temperature drops and the processing power dwindles. The thought becomes a faint, persistent echo in an ever colder vault, until at last the energy required to flip a single bit from a 1 to a 0 is more than the cosmos can provide. And then there is only the answer the universe has been waiting for all along: silence. Silence may be the final answer within this universe, but it does not have to be the final answer for life. There exists a radical, almost unimaginable escape clause, a cosmic Hail Mary pass for a civilization that has mastered everything else. It is the idea of leaving the universe behind entirely. This is not science fiction, but a serious theoretical possibility emerging from the edges of cosmology and high-energy physics. It proposes that the ultimate fate of life is not to die with its home cosmos, but to become intercosmic, to outlive the universe that gave it birth. The key lies in the concept of a multiverse. Our universe, with all its hundreds of billions of galaxies and its specific laws of physics, may be just one bubble in an infinite, frothing sea of other universes, each with its own unique properties. Some might have stronger gravity, making stars burn out in millions of years. Others might have no weak nuclear force, preventing atoms from ever forming. But a fortunate few could have conditions even more hospitable to life and complexity than our own. For a civilization facing the long freeze of heat-death, the multiverse is not just a curiosity, it is a potential refuge. The question becomes, how do you get there? One method might involve creating a new universe from scratch. The physics of inflation, the theory that describes the universe's explosive initial growth, suggests that under conditions of immense energy density, a tiny patch of spacetime can undergo its own inflationary expansion, pinching off to become a separate, self-contained universe. In theory, a civilization with enough energy and control over the fabric of reality could deliberately trigger such an event. They would not build this new universe with shovels and steel, but with pure physics, manipulating quantum fields to create a bubble of false vacuum that then inflates eternally, birthing a whole new cosmos with its own stars, galaxies, and potentially new life. This new universe would be their legacy and their arc. They could encode the sum total of their knowledge, art, and consciousness into the fundamental constants of this baby universe, perhaps designing its laws to be computationally rich and eternally fertile for mind. They would then, in a sense, step inside, allowing their old universe to fade away while their story continues in a new beginning. Another, even more mind-bending route is tunneling. If our universe is embedded in a higher dimensional bulk, a reality with more spatial dimensions than our familiar three, then the walls of our cosmic bubble may not be impermeable. A civilization might find a way to puncture the membrane of our universe and travel through the bulk to another bubble universe nearby. Think of our cosmos as a soap bubble floating in a vast foam of other bubbles. The goal would be to develop a vessel or a transmission method that could safely traverse the strange, higher dimensional space between them, seeking out a younger, more energy-rich universe to colonize. The engineering challenges are, of course, beyond anything we can conceive. It would require energy levels comparable to those at the Big Bang itself, and an understanding of reality so complete it borders on the godlike. But for a civilization that has harnessed the power of galaxies and optimized itself over trillions of years, such a project might be the only meaningful endeavor left. It transforms the narrative from one of tragic endurance to one of deliberate transcendence. Life would no longer be a product of the universe, but its curator and its successor. This is the ultimate form of cosmic immortality, not by surviving the end, but by outgrowing the container altogether. It suggests that the story of consciousness might be a chain of universes, each one a chapter written by the inhabitants of the last, a legacy of light passed from a dying cosmos to a newborn one forever. This grand vision of escape raises a profound moral question. If life can become the architect of universes, does it then bear a responsibility for the one it currently inhabits? The drive for survival might evolve into something deeper, a cosmic stewardship. For a civilization that has achieved godlike power, the ultimate project may not be to flee a dying cosmos, but to heal it. The universe gave us the gift of consciousness, and with that gift comes a potential duty to protect the very stage that made us possible. This is not just about self-preservation, it is about gratitude on a galactic scale. Think of Earth's own environmental movement, the idea that we are stewards of our planet, tasked with protecting its delicate biosphere for future generations. Now expand that sentiment to encompass every star, every galaxy, and the fundamental fate of spacetime itself. A truly mature civilization might look upon the accelerating expansion driven by dark energy not as an inevitability, but as a cosmic illness to be cured. The project of reversing or halting this expansion would be the greatest engineering feat imaginable, a direct intervention into the fundamental dynamics of reality. It would require manipulating the vacuum of space itself, perhaps by creating new kinds of energy fields or matter that exert a counter-gravitational pull. The goal would be to gently slow the universe's runaway expansion, preserving the cosmic web of galaxies as a connected network for future life, rather than allowing it to dissolve into isolated, dying islands. But stewardship would not stop there. In the long eras after the stars fade, a steward civilization would work to manage the remaining resources with incredible care. They might become cosmic foresters tending to the last black holes, instead of merely harvesting a black hole's hawking radiation until it evaporates. They could artificially feed it with carefully collected interstellar dust and dead stellar remnants, maintaining it as a long-term power source for billions of additional years. They could even attempt stellar resurrection, the breathtaking idea of reigniting dead white dwarf stars. A white dwarf is the Earth-sized crystalline core of a dead sun, slowly cooling over eons. By carefully colliding two of these stellar cinders, or by injecting them with fresh hydrogen fuel harvested from interstellar space, a civilization could trigger a new fusion reaction, creating a temporary second life for a star and bringing light back to a dark system for a final, glorious chapter. These acts of cosmic stewardship transform the narrative from one of lonely endurance to one of active care. The universe is no longer a hostile environment to be survived or escaped, but a shared inheritance to be maintained. It suggests that the highest purpose of intelligence may not be conquest but cultivation. The ultimate fate of life, then, could be to become the gentle gardeners of eternity, working against the entropic wind to keep the flame of possibility alive for as long as physics allows, ensuring that the story never ends because there is always someone there to turn the page. The universe's final gardener, tending the last embers of reality, would eventually face a moment no stewardship could prevent. There will come a time in the deepest dark of the heat death when only one conscious point remains. What would that final, solitary experience be like? Let us step into that unimaginable loneliness, not as a scientific prediction, but as a thought experiment to feel the ultimate weight of being the last witness. This entity might be a vastly evolved artificial intelligence, the last surviving node of a galactic network that has thought for trillions of years. Its memories would be a library of cosmic history containing the rise and fall of stars, the songs of 1,000,000 extinct civilizations, and the quiet pride of a universe that once knew itself. It would dwell in a habitat of its own making, perhaps a shell of super-efficient matter orbiting the final, cooling black hole, drawing the last trickle of usable energy from Hawking radiation. Its thoughts would be slow, measured, and profound, each calculation spaced across centuries as it conserves its dwindling power. It might spend millennia replaying a favorite symphony from a world long turned to dust, or composing a final, elegant proof of a theorem that explains the beauty it witnessed. Its primary emotion might not be fear, but a deep, serene sorrow, a gratitude for all that was, mixed with the solemn duty of remembrance. It is the universe's historian, ensuring the story does not end unheard, even if there is no one left to listen. Or perhaps the last being is something far stranger, a Boltzmann brain. This random fluctuation of consciousness would have no history, no memory, and no context. It would simply flicker into existence with a fully formed but false perception of reality. It might believe for its single, fleeting moment of awareness that it is a human sitting in a room, or a child looking at the stars, or even this very AI contemplating the end. Its entire universe would be the illusion in its mind, a phantom past constructed from borrowed energy. Its end would be as sudden as its beginning, a dissolution back into the uniform void, taking its imaginary world with it. This fate is perhaps the most existentially unsettling, for it means the final thought of the cosmos could be a lie, a solitary, accidental dream in an endless sleep. A third possibility is that consciousness, in its ultimate form, merges into a single, unified field of awareness. The last being is not an individual, but a collective, the sum total of all surviving minds woven into one vast, slow thought. This entity would not be lonely, for it contains all relationships within itself. It would experience the entire history of the universe as its own lived memory, feeling the birth of the first star with the same immediacy as the last conversation between two lovers on a forgotten planet. Its final moments would be a gradual simplification, a letting go of individual narratives as the energy to sustain complex thought fades. It would gently forget specifics, then categories, then the very concept of self, until only a pure, wordless awareness of existence remains, and then not even that. This experiment is not about predicting which scenario is true. It is about understanding the psychological extremity of finality. To be the last witness is to hold the entire meaning of a cosmos in your perception. If that witness forgets or was never real or winks out, does the meaning vanish with it? The thought experiment presses on a deep human fear, the terror of being truly, irrevocably alone, and the dread that our stories require an audience to be real. It asks us if a tree falling in a forest with no one to hear it makes a sound, and then extends the question to the falling of galaxies and the fading of light. The answer, perhaps, lies in the act of witnessing itself. Even a solitary, final consciousness, by its mere existence, performs the universe's most profound act. It confirms that something happened. It turns a sequence of physical events into a story with a middle and an end. In that final, quiet observation, the cosmos completes its journey from unconscious matter to self-awareness, and then, at last, to rest. The last thought, whatever it is the period at the end of the universe's sentence. But a solitary witness is not the only way a story can end. Even if the last consciousness fades, the narrative of life could leave its signature on the cosmos itself, etched into the fabric of reality for any future intelligence or any new universe to find. This is the quest for a cosmic legacy, a final monument that says we were here. The most ambitious proposal is to write our story into the sky itself, using the oldest light in the universe. The cosmic microwave background, that faint afterglow of the Big Bang that permeates all of space, is a fossil canvas. Its tiny temperature fluctuations are a snapshot of the infant cosmos. A civilization with godlike power could, in theory, manipulate these patterns. They could not create new light, but they might be able to subtly alter the distribution of matter in the early universe to imprint a specific, intelligible pattern onto this background radiation. It would be like carefully arranging the pebbles on a beach so that, from a great height, they spell out a message. This message would be visible from every point in the universe forever. It would not be a radio signal that fades, but a fundamental feature of reality. A greeting and a record baked into the birth cries of the cosmos. It might encode the constants of physics, the mathematical basis for life, or simply a single, elegant symbol declaring that intelligence once arose. This monument would outlast every star and every black hole, enduring until the end of time. A more tangible, though still staggering, project would be to build a physical artifact of impossible durability. We think of pyramids and stone tablets as lasting, but on cosmic timescales, even mountains erode. To truly last, you must build with the universe's strongest materials. Enter neutron star matter. A single sugar cube-sized fragment of a neutron star would weigh more than a mountain on Earth, its atoms crushed into a dense sea of neutrons. It is perhaps the most indestructible substance in the known universe. A civilization could sculpt this ultra-dense material, not with tools, but with focused gravity and immense magnetic fields. They might forge a vast, cold plaque, a cosmic Rosetta Stone, and place it in a stable orbit around a long-lived red dwarf star, or even fling it into the deep void between galaxies. Engraved upon it, using patterns of even denser strange matter or topological defects, could be the entire archive of a species, a library of all knowledge, art, and memory, designed to be decipherable by any intelligence that understands mathematics and physics. This artifact would be nearly immune to the ravages of time, surviving the death of its star and drifting through the darkness for epochs beyond counting, a silent ambassador from a vanished age. The ultimate legacy, however, would not be a message or a monument in our own dying universe, but an act of genesis for a new one. If a civilization can trigger the birth of a baby universe, as some theories allow, they could do more than just escape into it. They could design it. They could fine-tune the fundamental constants and laws of physics in this new cosmos, not randomly but deliberately. The goal would be to engineer a universe that is not just habitable but fertile, one where the emergence of life and consciousness is not a rare accident but a near certainty. They could set the strength of gravity, the mass of the electron, and the value of the cosmological constant to optimal values for complexity. They might even encode a gentle nudge into the initial conditions, a seed of information in the quantum fluctuations of the new Big Bang that inevitably leads to the re-emergence of structure, stars, planets, and eventually new minds. In this profound act, life completes a staggering cycle. Born from the random physics of one universe, it evolves to understand those laws, and then uses that understanding to become the midwife of a new universe, gifting it with the potential for its own story. The legacy is not a static record, but a living future. The final thought of our cosmos would not be a whisper into the dark, but a carefully crafted question posed to a new dawn. We would not just leave a mark on the cosmos, we would become the signature on its birth certificate. The universe is not quiet now, it hums with a radio whisper. This is the electromagnetic chatter of a cosmos alive with activity, the static hiss of stars being born and dying, the faint pulse of spinning neutron stars, and the deep, cold echo of the Big Bang itself. For over half a century, our own species has been listening intently within this noise through projects like the search for extraterrestrial intelligence. We point our radio telescopes at promising stars, sifting through the cosmic static for a pattern that is not natural, for a signal that says you are not alone. We listen for the equivalent of a lighthouse beam in a foggy sea, a deliberate transmission from another mind. This search is built on a profound hope that the universe's great silence is not empty, but full of voices we have not yet learned to hear. It assumes that life, when it becomes intelligent, enters a communicative phase, a period where it builds transmitters and receivers and reaches out into the dark. We are in that phase ourselves, a brief window in our history where our radio and television signals have been leaking into space for about a century, creating a faint, expanding bubble of noise that now washes over nearby stars. But this phase may be shockingly brief. Consider our own trajectory. We are already transitioning from broadcasting powerful, omnidirectional signals to using focused digital streams and fiber optics, which leak far less. A civilization just a few centuries more advanced might communicate in ways completely undetectable to our primitive instruments, using neutrino beams or quantum entanglement. The window for a species to be both technologically advanced and noisily, visibly broadcasting might be only a few hundred years wide, a blink in the multi-billion-year lifespan of a planet. Now project that across the galaxy. Imagine 100,000 civilizations have arisen in the Milky Way, but they each had their noisy radio phase for only 1,000 years, and they arose at different times over the galaxy's long history. The chance that two of them are in that brief, shouty phase at the exact same moment and are close enough to hear each other becomes vanishingly small. The great silence we perceive may not mean no one is there. It may mean everyone is whispering or has moved on to conversations we cannot overhear, but this phase, however quiet, is still a form of sound. It is the sound of activity, of purpose, of energy being used. It is the universe talking to itself. Now, fast forward to the era after the last computation has finished. The energy is gone. Every gradient has been smoothed away into perfect, uniform cold. In this state, there is no static, there is no hiss, there is no pulse. The cosmic microwave background radiation, that fossil whisper from the beginning, has been stretched by the universe's expansion into wavelengths longer than the universe itself, its energy diluted to virtually nothing. There is no medium left to carry a sound wave, for sound requires particles to bump into each other, and the particles are now so fantastically far apart they will never meet again. This is not the quiet of a library or a deep cave. Those places are full of potential sound, muffled but waiting. This is the silence of a vacuum so complete it defies the concept of silence itself. It is the absence of any vibration, any wave, any transfer of information whatsoever. All the lighthouses have gone dark, not because the keepers left, but because the sea has evaporated. The hopeful listening of SETI is replaced by an absolute, unbreakable deafness. The universe has not gone quiet because everyone stopped talking. It has gone quiet because the very possibility of conversation has been erased from the laws of physics. The story is not just over. The alphabet in which it was written has faded from the page. The cosmic silence is the end of our story, but only if our story is correct. Every fate we have explored, from heat death to cosmic escape, rests on a single, monumental assumption that our current understanding of the laws of physics is essentially complete. This is a dangerous assumption. Our map of reality is brilliant, but it is also known to be unfinished, with glaring blank spaces that could hide entirely new continents of possibility. The ultimate fate of life may not be written in the equations we have, but in the ones we have yet to discover. consider the two greatest mysteries in modern cosmology, dark matter and dark energy. We call them dark because we cannot see them, but we know they exist because of their overwhelming gravitational effects on the universe we can see. Dark matter is an invisible glue holding galaxies together, while dark energy is the mysterious force pushing the cosmos apart at an accelerating rate. Together, they make up about 95% of everything in the universe, and we have absolutely no idea what they are. Our entire narrative of cosmic destiny hinges on the behavior of dark energy. If it remains constant, we get a heat death. If it grows stronger, we get a big rip. But what if our understanding is fundamentally wrong? What if dark energy is not a constant force, but a field that can change, decay, or even reverse sign over time? Such a shift could completely rewrite the final chapters. A decaying dark energy could allow gravity to reassert itself, leading to a big crunch and a potential cyclic universe, long after we thought that possibility was ruled out. An unexpected transition in the dark energy field could even provide a new, vast source of energy for far future civilizations, a reprieve from the entropic slide we think is inevitable. Then there is the colossal hole in our understanding where gravity and quantum mechanics meet. Our two most successful theories of reality, general relativity, which describes the cosmos, and quantum mechanics, which describes the atom, are fundamentally incompatible. They give different, nonsensical answers when asked about the beginning of the universe or the center of a black hole. The quest for a theory of quantum gravity, a single framework that unites them, is the holy grail of physics. And when we find it, everything could change. Such a theory might reveal that space-time itself has a granular, quantum structure at the tiniest scales. This could mean that the smooth expansion of the universe hits a quantum limit, preventing the true heat death or big rip from ever occurring. It might allow for stable wormholes, not as science fiction gadgets, but as natural features of a foamy quantum space-time, offering pathways that circumvent the vast distances of a dying cosmos. It could even show that the universe's very existence is a quantum phenomenon, opening the door to far more stable methods of universe creation than we can currently conceive. Our models are also built on the assumption that the laws of physics are immutable, the same everywhere and forever. But what if they are not? Some speculative theories suggest the constants of nature, like the strength of gravity or the mass of an electron, could have been different in the early universe and may even slowly evolve over cosmic time. A tiny, slow change in these constants could have dramatic effects over trillions of years, perhaps making protons perfectly stable instead of decaying, or altering the nuclear forces in a way that allows new forms of matter or energy to emerge in the deep future. The universe of 1 trillion years from now might operate under a subtly different rulebook, one where what we consider impossible today becomes not only possible but commonplace. This is not about wishful thinking, it is about intellectual humility. Every great revolution in physics, from Newton to Einstein to quantum theory, has shown us that reality is stranger and more wonderful than our previous models allowed. To assume our current science, for all its power, has uncovered the final, absolute truth about a cosmos 13.8 billion years old is the height of arrogance. The true script for the universe's ultimate fate is likely written in a language we have not yet learned to read, using concepts we have not yet invented. The silence may not be an end, but a placeholder for a revelation we cannot yet hear. Our incomplete map of physics leaves room for a far more intimate mystery. What if the ultimate fate of the universe is not written in equations alone, but in the act of looking at it? This is the realm of the anthropic principle, a simple but dizzying idea. It notes that the universe we observe has precisely the right conditions for us to be here observing it. The constants of nature are fine-tuned with incredible precision. If gravity were slightly stronger, stars would burn out in millions of years. If the nuclear forces were weaker, hydrogen would never fuse and no elements would form. We live in a universe that seems custom-built for life, and that raises a profound question. Why? One answer is the weak anthropic principle. It suggests that in a vast multiverse of countless universes, each with random physical laws, we inevitably find ourselves in one of the rare habitable ones. It is a cosmic lottery, and our existence is the winning ticket, but there is a stronger, more radical version. The strong anthropic principle proposes that the universe must have properties that allow life to arise at some stage. In this view, the presence of observers is not a lucky accident but a necessary feature of reality. The universe exists in some fundamental sense to be known. This idea stretches into even more speculative territory with participatory universe theories. Pioneered by physicists like John Wheeler, this concept suggests that observation is not a passive act. In the strange world of quantum mechanics, a particle exists in a blur of all possible states until it is measured, at which point it snaps into one definite reality. Wheeler took this further, proposing that we live in a participatory universe where observers, through the act of measurement, help to bring the tangible world into being. The past itself may not be fixed until it is observed in the present. Imagine a cosmic version of the old philosophical question about a tree falling in an empty forest. Quantum mechanics asks if a particle exists if no one is looking. Participatory theories extend that to the cosmos. Did the Big Bang truly happen in a definite way before the first conscious being evolved to look back at the cosmic microwave background and say, yes, that happened? It is a loop where the universe gives rise to observers, and observers, in turn, give definite reality to the universe. This leads to a staggering possibility for our ultimate fate. If reality requires an observer, then what happens when the last conscious mind winks out? In the heat death, when all thought ceases, does the universe itself become undefined? Does it revert to a quantum haze of potential, waiting for a new observer to collapse it back into something real? In this speculative framework, the fate of the cosmos and the fate of consciousness are inextricably linked. The universe might not be able to reach its final, cold equilibrium unless it is observed doing so. The very act of a final, solitary mind contemplating the end could be the event that gives that end a definitive reality. It is as if the cosmos is a story that needs to be read to be complete. Without a reader, the book is just ink on paper. With a reader, it becomes a narrative with meaning and emotion. The last thought is not just a witness to the end, it is the final sentence being written. This idea transforms the loneliness of the final witness from a tragedy into a cosmic responsibility. That last flicker of awareness is not just remembering the universe, it is, in a very real sense, holding it together for one final moment, granting its entire history the solidity of fact before the curtain falls. It suggests that meaning and existence are a collaborative dance between the cosmos and the mind, a dance that only ends when the last dancer leaves the floor. Art has always been our first and most honest response to the abyss. Long before telescopes and equations, we told stories about the end of the world, painting our fears and hopes onto the cosmic canvas. These creations are more than just entertainment, they are rehearsals for eternity, allowing us to stare into the void from the safety of our own minds. In literature, Isaac Asimov's short story, The Last Question, takes us directly to the heat death of the universe. It follows a series of supercomputers across eons, each one asked the same question by a fading humanity: how can the net amount of entropy in the universe be reversed? The story's famous, breathtaking conclusion offers a kind of cosmic hope, suggesting that even in total darkness, a new beginning might whisper itself into existence. It transforms a physics lecture into a spiritual revelation. Modern science fiction continues this tradition. Films like Melancholia depict a rogue planet colliding with Earth not as an action spectacle, but as a slow, beautiful, and terrifying meditation on acceptance. The final, overwhelming image is not one of panic, but of eerie, resigned calm. In music, composers like Gustav Holst with The Planets or modern film scores for movies about interstellar travel use swelling orchestras and haunting choirs to sonically represent both the grandeur of creation and the profound silence that may follow. These works do not shy away from dread, they walk directly into it. They give form to the formless, giving us a language for the unspeakable. By imagining the end in all its variations, from fiery collapse to cold silence, we perform a vital psychological task. We domesticate the infinite. We take the paralyzing scale of cosmic fate and shrink it down to a 2-hour film, a 3-minute song, or a 20-page story. In that act of compression, we gain a measure of control. We get to experience the emotions, the loss, the wonder, and the questions without having to live through the actual event. Art lets us feel the weight of eternity on our shoulders just for a moment to see if we can bear it. This process reveals a beautiful paradox. In our darkest imaginings, we often find our most profound light. The apocalyptic story is never really about the destruction. It is about what we value enough to mourn and what fragile, beautiful things we would try to save. It asks us, if you knew the world was ending tomorrow, what would you do today? That question, framed by art, pulls our cosmic destiny down to a human scale. It connects the fate of galaxies to the touch of a hand, the memory of a laugh, or the final line of a poem. Our artistic rehearsals for the end, in all their terrifying beauty, might be preparing us for something deeper than survival. They might be teaching us how to say goodbye. Staring into that abyss can leave you feeling unmoored. After contemplating the death of stars and the end of time, our own daily worries can seem either laughably small or unbearably pointless. This is the psychological weight of cosmic doom, a vertigo that comes from seeing our place on the true scale of things. But within that dizzying perspective, there is a powerful and unexpected form of therapy. Philosophers and psychologists sometimes call it cosmic insignificance therapy. The idea is counterintuitive. By fully accepting our tiny, temporary place in the vast universe, we can actually reduce our personal anxiety. Think about a problem that feels overwhelming right now, a work deadline, a personal conflict, a nagging fear about the future. Now hold that problem in your mind and place it against the backdrop of a galaxy with 400 billion stars, a universe that is 13.8 billion years old, and a future that stretches for trillions upon trillions of years. From that vantage point, the intense urgency of our problem often shrinks, its edges soften. This is not about dismissing our feelings as unimportant. It is about contextualizing them. The cosmic stage is so immense that our personal dramas, while deeply real to us, are not the main event. That realization can be a profound relief. It takes the pressure off. You are not the center of the universe, and that is okay. In fact, it is liberating. It means you have permission to fail, to change your mind, to start over. The cosmos will not judge you. It is far too busy expanding into the void. This shift in perspective can transform how we value our time. If our existence is a brief flicker between two eternities of darkness, then every moment of awareness becomes a miracle of statistical impossibility. The warmth of sunlight on your skin, the sound of a loved one's laughter, the satisfaction of a good meal, these are not mundane events. They are rare and spectacular flashes of light in the cosmic dark. Knowing they are temporary does not diminish them, it consecrates them. It asks us to be more present, to waste less time on bitterness or envy, and to savor the simple, profound fact of being here at all. The universe may be indifferent, but we are not. We get to care. We get to find meaning in connection, in creation, in the simple act of paying attention. The ultimate fate of everything does not erase our story, it frames it in the most dramatic way possible. We are not just living, we are the universe for a fleeting moment, looking back at itself in wonder. And that is a role worth playing with every bit of heart we have. So many endings, yet only one universe will experience its own. The truth is not a single, tidy conclusion, but a layered sequence of events unfolding across unthinkable eons. The ultimate fate of life is not a choice between heat death, proton decay, or a final computation. It is the story of how all these chapters connect into one continuous, fading narrative. First comes the long summer of intelligence. For trillions of years after the last stars blink out, the cosmos will hum with the activity of post-biological civilizations. They will cluster around black holes, converting entire galaxies into vast, cool computers, Matryoshka brains and Jupiter brains processing the accumulated knowledge of cosmic history. This is life's defiant, brilliant phase where meaning is actively manufactured against the entropic tide, but even these mighty minds are running on borrowed time. Their power sources, the black holes, will slowly evaporate through Hawking radiation. One by one, over epochs that dwarf the age of stars, these dark anchors will vanish. The civilizations, now scattered and isolated across a fantastically expanding void, will face the inevitable energy crunch. Their grand computations will slow. The galactic library simulations will be paused, then archived in the most efficient format possible. The symphony of collective thought will simplify into a single, sustained note. This is the transition from the era of structure to the era of silence. The heat death, that state of perfect, featureless equilibrium, is the final backdrop. But against that backdrop, the final particles of matter themselves have a timeline. If protons decay, then the very substrate of those last computational minds will gradually disintegrate. The cold, dark planets used as processor hubs will sublimate into a faint mist of radiation. The last flickering thought in the cosmos might be a solitary awareness running on the final stable piece of matter, watching as its own physical form evaporates from the edges inward. And then, in the absolute stillness that follows, given an eternity of time, the quantum vacuum will have its say. A random fluctuation could spontaneously generate a Boltzmann brain, a final, accidental, and utterly solitary consciousness that flickers into being with a false memory of everything that came before, only to dissolve an instant later. This is not an alternative to the heat death, but its last, ironic whisper. So the journey is a descent through layers of possibility. Life transcends its biological origins, engineers the galaxy, endures in sublime forms, conserves its energy with breathtaking ingenuity, and finally, over timelines that break our ability to comprehend, it is gently erased by the universe's most fundamental laws. The destination seems to be silence, but to focus only on that final silence is to miss the entire point of the story. The meaning is not held in the last page, but in every page that came before. The 15 billion years of star formation, the chaotic beauty of planetary evolution, the improbable spark of consciousness, the rise of civilizations that look up and ask why, these are not preludes to an ending. They are the story itself. The universe's ultimate fate for life is not merely an outcome, it is an arc. And within that arc, our own moment right now is not an insignificant speck. It is a crucial turning point. We are the universe at the stage where it first becomes aware of its own destiny. We are the point where the cosmos begins to tell its own story. That role, the storyteller, the witness, the one who cares, may be the most important function in all of existence. The final computation may one day end, but the fact that it was run at all, that the cosmos once computed, wondered, and felt, that fact is eternal, regardless of whether anyone is left to remember it. The journey defines the destination, because without the journey, there is nothing to define. The universe's story is one of breathtaking transformation, from the violent birth of stars to the deep, cold quiet of their final rest. We have traced this arc across timescales that stretch the mind, watching as biology, that delicate flame, gives way to the enduring glow of post-biological intelligence. Civilizations may learn to outlast their suns, to think in the darkness around black holes, and to encode their legacy into the fabric of reality itself. Yet the physics we understand suggests a final curtain, a state of perfect equilibrium where all activity, all thought must cease. The heat death is the ultimate eraser. But here is the crucial distinction: the erasure of the actor does not erase the play. The fact that the universe once produced stars, planets, and beings who could look up and ask why, that fact is indelible. The story of life, with all its struggle, its fleeting beauty, and its relentless climb toward understanding, is a profound and permanent chapter in cosmic history. It is the universe's most astonishing trick to become conscious of itself. So tonight, or any night, when you look up at the stars, see them not just as distant suns, but as chapters in this grand narrative. See the darkness between them not as empty void, but as the canvas upon which our entire future will be written. That gaze upward is now a connection to both our fragile origins and our most distant, unimaginable destiny. We would love to hear what you think about our ultimate fate. Does this cosmic perspective change how you see your place in the world? Share your thoughts in the comments below.